recording. So in terms of recording, I'll just be posting these recordings in the Meetup link, in the Meetup section of Blackboard. So once, after each of these, I'll be uploading them to YouTube and I'll just be posting links there. So so the meetups will be accessible at a later time. And all right, so let's get started. First of all, can everyone see my screen? I just have Google Slides up.
Yes.
Cool, perfect. All right, so yeah, welcome to Knowledge and Visual Analytics in our first meetup. I am your instructor, Charlie Ferrari. And let's get started here. All right, so first, just to introduce myself, as I mentioned, I'm Charlie Ferrari. I work for Dow Jones, so I currently work with sort of more news data sources and helping clients do natural language processing on that. And I have a few of the previous places I've worked or different things that interest me. So I was at Plotly for a while, and will actually be using a few tools from them in this class. Previously at IHS Global Insight, if anyone has come across them, that's an economic forecasting company. And then this is a group called Beta NYC. When I had more free time, I would sort of work on more civic hacking projects. You guys will notice this with some of the assignments. I like using civic data sets, and I think that's a good way to, a great way to kind of hone our data science skills. So this image here is a screenshot of a project I worked on looking at cab rides in outer boroughs and sort of trying to analyze how many people are sort of taking these, taking cabs to like subway stations. So here, as an example, this is the Forest Hills subway stop, and you have patterns like this where you could, and this is sort of what ended up prompting it. I knew that there was a cab share route here where cabs would just pick you up, you pay $2 and they take you to express stops. And I just thought this would be a pretty neat way to see if this is happening elsewhere. And it turns out you get some pretty interesting patterns, mostly in other places in Queens, where things like this are happening. Oh, and I saw in the chat someone, Jane's user. Yeah, I haven't been at IHS for over 3 years now, but yeah, it's a blast from the past. Cool. So to further introductions, just to introduce what this class is about. So this is a data visualization class. You could sort of see how, really what this is about is, presenting quantitative information. And, I really see this as, I see this kind of more broadly as, a class about communication with data. So you'll see a lot of, you'll see kind of, communication around data being, a large theme. And then on the technological side, just speaking about what sorts of technologies are being used, I see this class as really being an intersection between data science and web development. So especially towards the last half of the class, we're starting out with R. So the first assignment, as I'm sure most of you have seen, is just using data visualization in R. Then we'll move on to Python. Broadly, this is really sort of a survey of different data visualization tools out there. But after we move from R and Python, we're going to start getting into more interactive data visualization platforms. So we start by going back to R with Shiny, going back to Python using a Plotly tool called Dash, a Plotly framework called Dash, which similarly allows people to build more interactive visualizations, and then finish up with some basic JavaScript and basic D3. So especially towards the end, you'll see how this really is kind of that marriage between data science skills and web development. In terms of general class info, class dates should be in the syllabus. There were a few hiccups there, but I think everything should be updated correctly. But of course, let me know if you notice there's a weekday where there should be a Sunday date. Every other week, homeworks will be due. So not this Sunday, but next Sunday. So not I don't have the calendar in front of me, but I believe it's. I'm not going to try to remember that date, but the dates are in the syllabus. In 1.5 weeks now, the first assignment will be due, and then every other week afterwards, homeworks will be due. We also have weekly discussions. So we just had our first, the half week before Labor Day. We kind of just had intros, but this week we had our first real discussion topic. And I'll put out an announcement about this later tonight or tomorrow. But for the discussions, try to aim around Thursday, getting in your discussion posts, and then you sort of have the rest of the time to respond to other classmates. And just in terms of my philosophy on how I'm teaching this, I consider sort of these homeworks to be like I provide some I'll provide some resources that I think may be helpful, but really, with these sorts of tools, it comes down to, more of a goal-oriented, project-based learning style. So, a lot of times it's just simply, technical documentation for whichever tool we're using. I have a few books that I recommend that I've found useful that I also will sort of provide to everyone. But it's really I see this as more very project driven. So we'll be focusing on sort of learning the tool with each the and then with the discussions, that's going to be a bit more where we talk about the the sort of more technical knowledge, that's the projects, and then during the discussions, that's where we'll talk about the more general data visualization concepts. So as you'll notice from the discussion from the instruction, the prompt in the first discussion post, I'm using, and I'll go through a few sort of big thinkers in the field of data visualization, but Edward Tufte is pretty much the go-to person, and he has a lot of sort of best practices, like good concepts in terms of ways of thinking of data visualization, and what I sort of use the discussions to do is link that to more modern uh, more modern environments. The sorts of things that we'll be thinking of is Edward Tufte's principles. Uh, his and if you look up any of his books, uh, they're pretty interesting, and they're really meant to work in a more kind of static visualization world. And so what I really want to try to do is sort of see how these sorts of concepts apply when we bring in more interactive visualization environments. So especially like web-based visualization tools. And then lastly, at the end of the semester, you will complete a larger project using public data. The this will be due on the same week as homework 4, but there will be a proposal that everyone will have to complete by then, and then I'll provide more feedback on whichever topic you choose, and then you'll be ready for your final project. And then everything is available on the course GitHub page. So if you've looked at where the assignments are posted, usually they're just linking to the GitHub page. So keep an eye on that. You might have to do some cleaning up of that because I ended up shifting around some of the modules. For now, like modules 1, 2, 3, and 4 should be okay, but if you are going ahead, just keep that in mind. Although this will be fixed before the second assignment, I would say. Any questions about just general logistics? Cool. All right, and this is just mentioning GitHub. So with this first lecture, with this first meetup, we'll be going through just general technique and theory around data visualization. For most, I have some other topics that I'll go through in future meetups, but in the future, like most I would say sort of the meat of most of these meetups are going to be going through projects that we've already worked on, and looking at different solutions to the questions there. So there'll be some mixed, but this is going to be sort of the most kind of standard lecture meetup that you'll have. So first we'll just talk about the importance of data visualization. So does anyone know what this is a photo of?
Challenger.
Yep.
Space shuttle.
Yep, exactly. And who was that, by the way? That was Sergio?
And someone else, but yeah, both of us.
Oh, okay. Cool, but yeah, you were both right. This was the Challenger explosion, and this happened, forgot which exact year, but I just realized it's right there, 86. This was just a pretty horrific disaster for NASA. But it also has, and this is actually coming from Tufte's book. I apologize, bear with me for 1 second. Sorry about that. Can everyone see my screen again?
Yes.
Cool. So Challenger disaster happened in the 80s, and this was, and Tufte writes about this in one of his books, really talking about how this was, in one respect, a failure of data visualization that really led to the decision to launch the rocket when perhaps it shouldn't have been launched on that day. So these are just a few pictures of the Challenger before it launched, showing what actually ended up happening. And so you have these rockets and these booster rockets, and then on the booster rockets you have what are called O-rings. So you can see this arrow pointing to where one of these rings failed and resulted in a fuel leak. So you could see the fuel leaking. The fuel was leaking onto the uh, burning rocket. So that's really the mechanism that caused the explosion. And Tufte and Tufte brings up that, so this is from his book Visual Explanations, and this was essentially the visualization that the that the engineers were using in order to decide, make decisions about whether or not they should launch. So um, the sorts of variables that we're looking at here in particular is temperature, and then in various test launches where there were failures. So you could see each of these represent a test. You could see like where there were failures. So here on this trial, there was a failure in this O-ring over here. In this trial, there was no failure. There are two rockets each because it's the two side booster rockets, and so something like this gives you an idea of what information they were using, and really what this is meant to drive home is how there are sort of better and worse ways of presenting the exact same information. So just looking at this visualization here, does anyone notice any patterns? Like what sorts of, is there anything that sticks out to anyone? Given the sorts of information that we're looking at, uh, temperature and failures, and obviously we're trying to avoid failures.
Lower temperatures seem to be associated with failures.
Okay, so so it's interesting that that is correct, and it's but I'm sure you would agree that it's kind of difficult to tell that that's exactly what's happening here. If you're really keeping track of what the temperatures are, you'll see that you have sort of 57-degree day here, 53-degree day here, where there were lots of failures. But you also have things like on this launch, it was a 75-degree day, and there were two failures. So there's uh, so there are some things that might throw you off, and overall, it's kind of hard to really judge the pattern. And actually, uh, in terms of what was happening, there were actually, there was disagreement about whether whether the shuttle should have launched that day, and because this was the visualization that people were using, it's hard to really um, get that point driven home. So Tufte reimagines that visualization in a way that would, show more clearly what's going on. So um, the information that's shown here is exactly the same as the information that's shown here. The exact same data points, but here it's a bit more clear what's happening. And it's also a bit more clear why there's some, why kind of it really makes a difference visualizing things in a more effective way. So for example, I had mentioned that there were failures on like so it was picked out that it was cooler temperatures that were resulting in failures, but there are still failures on more temperate days, and here you could clearly see there are still failures, and there's also kind of this visual effect here. It's not really, you wouldn't really notice this statistically. It's more kind of something that makes itself clear, in a visualization. So you see sort of you see like a few failures over here, but then you begin to see the pattern that as you get to these cooler temperatures, there are no successful runs, and you sort of have increasing failures as temperatures begin to fall. And then right here, this is the temperature range that was forecasted for the day of the Challenger launch. It's kind of strange. Like, this is in Florida, so this is definitely an unusually cold day for Florida. But looking at a graph like this versus a graph like this, it just becomes abundantly clear that the decision to launch on a day like this was ill-informed. And then this is just an example of a few other bad visualizations here. So some of these, it's clear what's bad about them. So in this pie chart, you can see we're not even adding up to 100. So this is definitely not the right way to show this sort of data. In this graph here, does anyone want to take a stab at why this isn't as successful a visualization as it should be?
A lot of visual noise.
Yep, exactly. And we'll get into this in a bit, but Tufte has a visual principle called small multiples, which would be useful to visualize these without everything being on top of each other. And then we have perhaps some ill-informed decisions of trying to map a visualization to a more visual a sort of circular representation of time, or this bar chart. Does anyone have an idea of why this isn't a good visualization?
Look,
The
a couple of
years are
things. Sorry, go ahead. I was just going to say a couple of things. One is you have a redundant, the labels on the y-axis are kind of redundant with the numbers on the bars, but then the x-axis, it's kind of unclear how the years are ordered.
Mm-hmm. So there's actually, I'm sorry?
And the scaling of the x-axis too, starting at 53 and here at 55 and a half.
Yep. Yeah, so that scaling of the y-axis is definitely, sort of the major thing that's wrong with it. Some of those other suggestions, like, the labels on the y-axis perhaps being superfluous, that's more, kind of general visualization principles. So we'll get into, the data-ink ratio. That was actually the first topic in the discussion board. So you guys have some exposure there, but really, what makes this, a truly bad visualization is that when you do have a bar graph like this, you need to zero index your y-axis because there is and also with the with the years, that's another thing to keep in mind there. Like, here you have sort of the years are ordered as the numbers are increasing, but you end up with 98 being later than 2006, with 99 being back here. So that's just like this graph is just a mess in a lot of ways. So, one way of speaking of the goal of, the goals of data visualization, you could see laid out right here. So, and we'll kind of map these to a few, general concepts that a lot of times are coming from Edward Tufte. But and one of the things I focus on is sort of, a lot of kind of restating of these concepts in different ways. So, saying things like, minimizing mental effort. This is really the concept behind data visualization in, itself. Like, why do we even bother doing data visualization and not just, like, why aren't we all looking at, tables all day? It's because, images are just that much more efficient in communicating their points than just looking at a table of data. And then sort of mapping this to things like human memory is just more visual. So, humans won't really have a direct connection to the raw data itself, but there will be more of a connection to a trend line or to other visual patterns. And then sort of this insight over beauty is kind of focusing on sort of the, again, efficiency of communication. That it's great for things to be beautiful, but really the focus is on is on sort of what are you trying to communicate and how successful are you at communicating that. And these are sort of the three top strategies that come from Tufte. So matching the display to data and purpose, maximizing the information to ink ratio. So what that means is, as you saw in the discussion post, it, sort of think of it as minimalism in data visualization, that when you are looking at your visualization choices, think about all of the visual elements in the visualization that you're making, down to sort of what tick marks you have, what grid lines you have, and just think, how much, are these elements giving, are they leading to more insight? If they're not leading to more insight, then is there a more efficient way of communicating that? And then another, I believe this is going to be in 2 discussion posts. So in 2 weeks, we'll be talking about the principle of small multiples. And that's just a, sort of a better way of sort of making comparisons between different variables, which we'll get into. But first, we'll talk about matching the display of data and purpose. And I forgot to add this link to Blackboard, so I will add this after the lecture. But this is a professor named Tamara Munzner. Edward Tufte sort of focuses on, sort of just general aesthetic sort of strategies when working with data visualization. But Tamara Munzner kind of focuses more on, kind of the neuroscience bases behind all of this. So a lot of her research is about, sort of not just, going through these strategies of data visualization, but, talking about why these choices make sense given human sort of the structure of the human brain. And so you'll see we have 3 major types of data: relational, spatial, and tabular. I'm going to be spending most of our time looking at tabular data, but we'll start out just sort of introducing all 3. So starting with these two, relational data, you could think of this as just links between points. So things like, family trees, maps of international trade where you're looking at links between like bilateral trade relationships, types of data. So this visualization that we're working our way through at the moment, this is relational data that we're looking at. Um, and then you have spatial data. Spatial data is data where it's inherent, where there's some sort of inherent position, some sort of inherent, like and maps are sort of the go-to example, given that this is called spatial data. So with maps, you have longitude and latitude, and that longitude and latitude is referring to a particular space in reality. And then but you can, so maps is the vast majority of this sort of spatial data, but you could also think of things like star maps. If we're looking at the location of stars and galaxies, those are also sort of corresponding to their intrinsic positions someplace. And then with tabular data, this is really the vast majority of data that you'll be dealing with. And you can see that you have a lot of different types of data and tabular data that will inform what sort of visualization strategies you use. So you could see two major types, and that, but really three types of data being discrete, continuous, and categorical. So data like categorical data, you could see sort of different types of fruit, different, if we weren't looking at the locations of countries, we were just looking at the countries themselves, that could be seen as categorical data. Then we have things like continuous data, where it's an actual measure of something. So you can see the examples here, 5 kilos or 5 kilos, 2 ounces. Anything that, really is a measure of something is considered continuous data. So anyone think of any other example of continuous data?
Stock prices.
Yep. Stock prices, like really, people's height, basically anything where there's, some sort of measure, and that measure could be anything, anything of those units. And then lastly, you have so this is within ordered data, so categorical data. It's distinct, but there's no real order to them. So if we are looking at countries, we may be there may be some measure that kind of suggests an order, but the categories themselves aren't ordered. So there's nothing inherent in countries that orders them. Whereas with discrete ordered data, there's, it's similar to categorical data. So things like small, medium, large, or extra large, like sizes of clothing, it's, similar to like you could sort of think of those as similar to categorical data, but the order of these sizes matter. So, if you have things like a 4-phase project and you're looking at the first phase, second phase, third phase, fourth phase, that's something that's discrete and ordered. Any questions about these, sort of overview of different data types?
What about combining categorical and continuous data in a single view?
Um, so when you say combine, do you mean like in a table, like a data frame or something?
Well, one of the things that we have found out so far is things like linear regression,
Hmm.
where you combine both categories, categorical and continuous data. So I'm just wondering, it makes sense to have a representation of both. Uh, might be more tricky than that.
Yeah, and I guess I wouldn't really consider that combining the data. And perhaps the best way to think of it would be like when I say something is categorical or something is, or when one says something is categorical or continuous, really what you're talking about is a variable within the data set. So let's say we're looking at GDP across time, with for different countries. So let's say we're looking at the U.S., France, and Canada, and we have 10 years of data. So we have um, 2009 to 2019 yearly, and we have sort of a dollar value. So that's sort of imagine a data frame with three columns there. Um, the country column would be categorical. The GDP, the actual dollar value, that would be continuous, as well as the year itself. That's a continuous variable. Like, does that make sense?
Yeah, makes sense.
Cool. Cool, but that is a good point about because we will as you see some of the examples, like obviously you are going to be combining these things a lot, and the kind of like these are the sorts of questions that will inform what kind of visualization that you're looking at. So let's using the country GDP as an example, like let's say we were only looking at one time period and we wanted to make a comparison across different countries. How would we do that versus how would we like what if we were looking at one country but we wanted to show GDP growth over time, like which like there would be different visualization choices that we would make in both of those cases, being informed by the type of data that we're looking at. So now that we've gotten all of the data types defined, we could sort of think about like what are the best ways to display this data. So for spatial data, this is really the most straightforward. Pretty much going to be in mapland with spatial data. So you have, and it could even be a star map if you're looking at sort of stellar locations. So you don't have too much freedom when you are looking at purely spatial data. For relational data, however, you have a few choices. And this is also coming from Tamara Munzner's work. And, she's really trying to, get at the core of, 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 of what it means, these display choices. So, you could see we're not like we don't have things like bar chart, line chart in our sort of ways that we're displaying data. We have concepts like contain, connect, etc. And so these are meant to really apply across different different visualization types. So for relational data, we have sort of as the most, and these are in order, by the way, of most effective to least effective. So, as most effective, we have this concept called contain, which, at first might be kind of confusing. So, does anyone have an idea of a data visualization that is, that would be using this sort of principle of contain?
Venn diagrams.
Exactly. Yep. So so if you're thinking of two different, that's a perfect example of contain. Where you have two sets, you have some sort of overlap, and you're using a Venn diagram to view that. So that's using sort of this contain principle. And then you have sort of other connect. That's sort of what we were doing over here. And then things like similarity or proximity being lower down. And then for ordered data, you could see a few of these. Like these are a bit more easier to imagine in visualization types. So for position, for example, like this is basically a scatter plot. So a scatter plot is dots that are representing position, and really the way to sort of think about like why things are ordered in this way, and you can see it pretty starkly when you make the comparison here between length and area. So as an example, if we're looking at length, about how which of these lines would you say is longer? I mean, that sounds like a trivial question, but you'll see why I'm asking that. It isn't a trick question, so.
The one in the middle.
The one in the middle. So yeah, the bottom one is longer.
Sorry.
Huh?
Yeah, I was watching a different one.
Yeah, so the one on the bottom is the longer one, and I bet like people would have a pretty good idea of how much longer the bottom one is than the, like if anyone wanted to guess about how much longer the bottom one is than the top one. A rough estimate.
20%.
I'm sorry, what was that?
20%.
Yeah, that seems about right. I like around 20%. Like I sort of see this as 3/4 the length, so like 20-25%. With length, it's pretty easy to see that this line is twice as long as this other line. That's something that's pretty well mapped to human intuition. But something like area is different. So if I were to ask that same question about these squares, it's a harder question to ask, and I'll get into this in a later slide. But there have been studies of these different essentially how does the human ability to judge change map onto what's happening in reality. And it turns out that with something like length, it's almost a perfect one-to-one. Like we're really good at being able to sort of look at these two lines and make that judgment. With area, not so much, because there's like if I were to say this box is I mean, you could sort of get that this is like around a fourth the size of, a quarter of the size of a box. But, if I were to say like, can you draw a box that's a third of the size or half the size of this one? That would be kind of difficult to do in an intuitive way. So, that's really kind of the best intuitive explanation of why we're ordering things like this when we're looking at these different, strategies for visualization. And then lastly, we have similar information for categorical data. So things like position, color is a very popular one, shape or patterns. And so on the next slide, I'm going to quickly flip to it, but what I want to try to do is sort of just show another example of, really what we're looking at when we're thinking about, matching the display to purpose. So, what I want, I'll ask when I sort of flip to this, what is the first thing that comes to mind when you see the visualization, like just very quickly? So, I sort of flashed into that. I'll flash very quickly again. So, what sorts of things were sticking out to people? It could be anything random that you happen to notice.
I saw a normal distribution. What it look like to be a normal distribution, real quick?
Okay, normal distribution. Anyone else have anything they saw?
2 trends, 1 red flat line.
I'm sorry?
2 trends, 2 trend line, and 1 red flat line.
Okay. Yep.
Yeah. It almost looked like it could be a time series, a blue line and a red line.
Mm-hmm. Mm-hmm. All right, cool. So, so what this, really was looking at this. People who saw a time series, they happen to be correct. Although, definitely it's understandable. These look a bit like standard normal distributions, and people saw, someone saw the red line. People saw that there was some sort of trend. I bet if I sort of continued asking, like, what was that trend, people would have picked up that, there was sort of a rising trend and then a falling trend. So you could see things like, the most important thing that we're looking at is housing prices, so that's using this positional ranking. For time as well, we're using a pretty highly ranked channel. And then, we sort of have this, comparison that we're making with city. So that's using, sort of a slightly, less powerful channel to map onto. So you have things that are more important, things that are less important. And one thing, because our first homework is going to be in R, and R uses ggplot, just sort of giving some examples of the ggplot code. And I'll get into this in some later lectures, but something like the grammar of graphics, it's a pretty powerful conceptual framework for thinking of data visualizations. Just simply looking at something like this, realizing that we have 3 channels that we're looking at. We're mapping year to X, we're mapping price to Y, and we're mapping our color to, or city to color. And then moving on to some other concepts, and I think I'm going to move a bit more quickly because we're sort of reaching the end here. So maximizing the information to ink ratio. This is really about like being most efficient in what it is that you're presenting. And the logical endpoint of something like this is spark lines. So with spark lines here, we're keeping y-axis labels, but you could even imagine removing those and just really getting sparse with what it is that you're showing. I have some examples later on where we're even going further than spark lines and just simply doing a start and an end period. So there's there's a lot of distraction that you could remove from your visualizations. And then the principle of small multiples. This is real. What this is really meant to say is it's easier to compare things next to each other than overplotted. And stock prices are a really good example of this because with stock prices, what really matters is kind of the price trend here. So you see the you sort of see the trend of Apple compared to BlackBerry, this is an old chart, so I don't really know what it's definitely changed now, but like, if you sort of look at this trend, like the levels are different, like Apple prices are in the hundreds, BlackBerry prices are in single digits. If you were to overplot these, you would get just a flat line down here for BlackBerry. It would probably end up giving you a flat line up here for Apple, and you would be left with no information. Whereas, if you're comparing them side by side, you're able to see that, there are similarities in, you have this sort of trough right here. You have this general uptick towards the end. So you could sort of see these similarities where they wouldn't be evident elsewhere. And again, just looking at how something like the grammar of graphics would treat something like this. So we're, like mapping our variables to different, kind of aesthetic mappings. And you could see sort of an X, Y, and in this case, sort of faceting. ggplot calls it faceting, but faceting is basically we have company name and we're sort of dividing the facets by that. And this is this is another data visualization thinker, Scott Baronato, who sort of speaks about other ways of dealing with this problem. And another way is just to simply make sure that your measures are comparable. So if we are, and he uses sort of the prices of gold and silver as an example, when we have, and this is sort of, it's never really a good idea to have left and right y-axes like this, because you could sort of see it's giving you similar patterns like this, but you get much more information when the measures are comparable. So here, there's really what amounts to arbitrary cutoffs on both of these y-axes. Here, what we're seeing what really matters. We're comparing a percentage change, and we're getting just that much more information out of this. So in particular, there are similar patterns which you get from here, but you could sort of see that silver is kind of a bit more widely fluctuating. So you have higher highs and lower lows that you don't really see in a graph like this. And these are just some examples of small multiples in practice. So things like Google Analytics. These examples are coming from Edward Tufte. So looking at something like this, we have a bunch of funds. We have some performances, and it's pretty easy to see that there's an outlier here. Does anyone have a guess as to why there's an outlier here? I guess before we
versus bonds.
Yep, exactly. So all of these are stock indices, but this is a PIMCO bond index. And this is getting back into Scott Baronato and a few of his concepts. And one of the things I've noticed in kind of looking at his concepts is you could think of him as reframing a lot of these strategies. It's similar concepts, but he's just saying it in a different way. So one of his concepts is that visualization choices are informed by, the point that you're trying to, get across. And you could think of this as kind of a conceptual version of maximizing information to ink ratio. And I'll sort of go into that with an example here. So, you have this text, which is comparing, census measures across, rural, suburban, and urban areas. And, there's few paragraphs here. You see a few numbers. So there's a set of information here. And this you could almost think of as kind of a picture is worth 1,000 words, but the numbers, the raw content that's here, it's all reproduced here, but the story that's being told by this visualization is just so much more clearer. So one of the things is we're looking at a change between year. So this is even going beyond spark lines. We're not looking at trends. We're just simply looking at what the change between 2 points. Like this has been kind of a concept I've been seeing out there in places like 538 or the Upshot. We're looking at sort of these changes. We're looking at, we still get the sort of information about population, and it just, in a more visceral way, communicates what is being put out here. And I also, sort of take this to mean, like when we are talking about sort of the conceptual version of, data inc ratio or concepts like that, really what you need to think of if you're creating a visualization is what you're, planning on, communicating. So using this as an example, I have vinyl sales charted out since 1993, and it seems like there's a pretty solid story here that vinyl sales are being driven to unprecedented levels. But the context, when we are talking about visualization choices, in this conceptual way, context really matters. So, you could see how the story drastically changes when you change your context. So, this is really kind of a good rule of thumb here. Like, I'm not technically lying with this visualization. I'm just, sort of changing the context in such a way that it's sort of guiding a viewer to a particular conclusion. And then lastly, this is this is what I had mentioned before about looking at, when we were talking about length versus area, and this is giving a few other, sort of either experiential or different qualities, and how humans are able to notice changes in them. So here you could see perceived sensation versus intensity. So perceived sensation meaning I perceive this line to be twice as long as this other line, and what is happening in real life. So if you have a one-to-one relationship, you're pretty much spot on with reality. I see a line that's twice as long as this other line. That line is in reality twice as long as that other line. But when you get to something like area, you could see, that there isn't that one-to-one relationship. So there's actually a lower perceived sensation, when compared with actual intensity. And on the flip side, you have things like color saturation, black and white lightness, or even something like electrical current, where these are all sort of experiences, and this is how we're experiencing it versus what is actually happening in reality. And then one more thing to keep in mind is just discrimination. So this is, these are just some general rules of thumb in terms of, when we are picking different scales. So, for a pie chart, because what pie charts are is essentially area. You don't want to have too many categories there. For colors, keep things around 7 categorical colors. For scales, it's different, but this is more discrete things. And around 4 overlapping lines before you begin to resort to concepts like small multiples. And so we're approaching the end. I really wanted to sort of get a real life example here, to try to sort of, get an intuitive handle on a lot of these concepts that we've been talking about. So there's a lot going on here, and what I thought would be fun would be to look at a political map that isn't as sort of knowable, assuming most people, assuming most people here are pretty well aware of American politics, that isn't as sort of immediately knowable, as sort of American politics. So this is actually looking at the 2011 federal election in Canada. And what I'm going to try to do is try to see if, given, the information that we have here, can we, try to find out the story behind this election. So, there's two major visualizations here. There's this over here, which is looking at, Canada has a parliament, so ridings are basically like house districts, and so we have sort of a map of how the various parties. It's parliamentary, so we have more than the two that we're used to in American politics. And then this one on the left here is sort of showing the change from the previous year. So you see this is divided by province, and you have sort of if it's solid, that means that there wasn't a change in party. If you see sort of this little color over here, that means that there was a change. So, and if anyone on the call is Canadian, then I'd say let other people guess what's happening if you already know the story behind this election. But does anyone want to take a stab at what happened in this election? So, and I know this is like a broad question, but just really, take a minute to look at these two visualizations and, just see if there's any pattern that you pick up on, anything that, perhaps might be sort of a story, sort of a reason why I picked this election to show off.
Nobody had a clear majority.
Yep. So that is correct. No one had a clear majority. That's pretty common in parliamentary systems. You always have to sort of. Actually, I'm sorry. Conservatives had the. That's right. The yeah, I got confused there. So actually, in this case, the Conservatives had the majority here. But in a lot of parliamentary systems, you don't end up with a clear majority, and you have to form coalitions. So in particular, I would see if there's any, if anyone notices any patterns on the left-hand side here.
So this new democratic party, assuming that it's new, is starting to make inroads in the Canadian elections.
Yep. So yeah, so that's actually that was actually spot on. And this election, usually the two major parties in Canada, it's the Conservative and Liberal Party. But the Liberal Party, like at this time, there was sort of a scandal that they were suffering through, and there was, and you could sort of see they did not do well at all in the election, and the new Democratic Party ended up really gaining ground. And if you look a bit closer at the sort of changes in party, you'll notice like sort of a lot of things about kind of where this resurgence is coming, where this sort of surge is coming from. So looking at Quebec, for example, you could see a lot of the this sort of light blue over here, and reds over here. So this is Montreal, what I'm circling over here. So there, it was really the New Democratic Party taking taking power away from liberals, and what the light blue is sort of representing is it was the New Democratic Party like taking power away from the Bloc Québécois, which also wasn't doing too well in this election. And sure enough, that is pretty much what was happening. There was this NDP surge, the New Democratic Party. The Liberal Party was trounced. The Bloc Québécois was trounced. This is actually, I'm actually a McGill alum myself, but there were, McGill poli-sci students would, sort of work on NDP, campaigns, and some of them even ran for office just to have the fact that they ran for office on their resume, and never expecting to win, and some 4 random students who had no political experience ended up getting voted into parliament. So so you could see that something like this, I would say, is a successful visualization. Like we were able to sort of get some of these concepts from the. We're able to get some of these concepts from just looking at this visualization. And I'm sorry. Okay, and we are approaching the end of time here, so and I don't really have time to go into these others, but I had a couple of other comparisons, in terms of visualization types. Just one other thing I wanted to note over here is, one thing that I found kind of interesting about this particular visualization is because we're looking at, a different type of political system, we have sort of this weird mapping over here. And, this is actually 2 scales that we're looking at. We're looking at sort of a, categorical scale. So we're looking at the different parties, but we're also looking at this popular vote of the winning party by writing. So, if you have this color over here, this represents a conservative win, but a narrow conservative win. And and something like this, I would argue it. This is actually one of the features I think is the worst about this visualization is you have these 2 sort of competing scales. Here you could see it's sort of almost 25 different it's 25 different discrete colors, and especially when you get towards the higher popular votes, it's very hard to discriminate between them. So in this way, I thought that was something that wasn't as successful in a visualization like this. So what I want to do before we go is move on to homework number 1, and just quickly see if anyone has any questions on that. So the homework has, it's an R Markdown file. So the R Markdown file pretty much provides the template that you could use to to create your visualizations. We're looking at company level data, the Fortune 500 companies, and some stats about them. But does anyone have any questions on the homework so far? Ritesh, you're right. We are starting at 7:45, so I'm going a bit over with my previous section, and we will start. We will start momentarily. So yeah, I apologize for the confusion if anyone else had jumped in from the second section. And if we don't have any questions on the homework, I'll just kind of move into our second section. So I'm gonna be keeping the this meeting open. So anyone coming in from the second section, this is the correct place to be. And everyone from the first section, thank you so much, and I look forward to a great class with everyone.
Thank you very much.
Professor, I had one question.
Yes.
I think this 7:40, the 7:30 to 8:30, I think works better for me. Is it okay from next week I can join this session rather than the 6:30?
Yep. So in terms of sections, like feel free to bounce between either of those. The only it does start at 7:45 rather than 7:30, but other than that, you're free to do the later section.
Perfect. Thank you, Professor. Have a good day. Thank you.
You too. All right. So for anyone who did join from the second section, you're not late. That was just the first section going over. So we'll get started in a few minutes. So look forward to starting things again with you guys. So I'll probably give everyone a few more minutes, let section 1 people leave, section 2 people come, and we'll get started. But in the meantime, if anyone from section 2 has any questions they'd like to ask before we get started, feel free to ask away. So for anyone who's just joining, welcome to the second section first meetup. We'll be getting started shortly. I'm just waiting for a few more people to come in. But if anyone has any questions in the meantime, feel free to ask.
Hi, Professor. This is Simon.
Hi.
Hi. I want to clarify a little bit about the discussion homework on data-ink ratio.
Mm-hmm.
So we're supposed to read the New York Times article and then answer the 3 questions that you posted, right?
So the New York Times article, and let me share my screen so I could go into the discussion post. So this first topic, the data-ink ratio, the New York Times article was meant to be just an example of a sort of visualization in sort of the medium of the web. And in terms of the theme of these discussion posts, we're looking at data visualization concepts from Edward Tufte. He's a major thinker in the field of data visualization. And what I'll be doing is relating those to the web. And so really what the prompt is to just sort of look at this. So really the theme of this is Tufte's concepts are meant to, they're sort of more classic. They're meant to, really apply to static data visualizations. And what I want everyone to think about in this and future discussion posts is how can we think of these concepts when we look at different mediums of data visualization. So like, more specifically, like interactive visualizations made possible by the web. So for example, if we're when you're thinking of the data to ink ratio, usually, you're thinking of just literally how much ink is there on the, on your visualization. But, what if you have an interactive visualization with a drop-down menu? Are these different interactive elements also subject to data ink ratio? Are they not? Are they sort of subject in a unique way that makes it different? Does that make sense?
Yes, I just wanted to clarify more on what to base the answers for. I mean, what material to read first before answering these questions. So I guess the New York Times article and the and what you mentioned.
So I'll provide all of the material in. So basically, like this. And do you see my screen, by the way, Simon?
Yeah.
Okay. So this section up here, this is not going to change week to week. Like this is just an explanation of the prompt. And then down here, this is where this is what will change week to week. So this week we're discussing data ink ratio. There's a link over here that sort of leads to a description of what the what data ink ratio is and what does it mean. Yeah, what does it mean to get a high versus low data ink ratio? How does that affect your visualization? And then what the prompt really, and you can see in this sort of animation as well, what it looks like to make your visualization more efficient. And then the real prompt is going to be looking at, trying to find examples of, what this looks like in, different in different mediums. So, for example, and I will get into this like towards the end, but the the preview of what we're going to go into. But you could see here, like this is an interactive visualization where you're going over points, and you have sort of, you have this concordance between these points and the municipality.
The map areas.
Yeah, exactly. And the so the question is like, how do you think about data ink? And this isn't the best example really, but really what I would think of is like, imagine a sort of imagine like if you have 12 drop downs in a dashboard, is that sort of violating the principle of maximizing your data ink ratio, or is the fact that we're in this interactive medium just sort of such a drastic change that this concept no longer applies?
Mm-hmm. Okay, understood.
Yeah, and also try to be, and this is true for all of the discussions, but try to be, example driven. So, for each of them, I ask like, provide an example. I don't worry about, things like repeating examples, or, I don't want this to be sort of an endless exercise of just everyone trying to find obscure data visualizations, although that could be fun. But, I like this being sort of example driven. So sort of, if your case is that, data ink ratio means something different when we're talking about interactive, elements of a visualization, provide an example that, sort of makes that case and say, I believe this because look at this example. It's clear that, something like that.
Got it. Okay, appreciate it. Thank you.
Yep, no worries. And I'll see anyone else in, if any, so Sudan, or someone who just asked about sort of making a later meetup. Just in general, this is the second section, which starts at 7:45. There's a first section of this class that starts at 6:30. And they're both on the same day, so it's every other Wednesday. If you have a preference for one or the other, feel free to join whichever fits your schedule. And in addition, we'll be recording all of these, and I'll post the links. I'll upload them to YouTube and post those links in the meetup section. So that's that. And then I'll actually get started here. So we'll. So if any other questions before I begin? Or cool. So let's get started. Welcome to Knowledge and Visual Analytics. I'm your instructor, Charlie Ferrari. So to start out, just by introducing myself, I currently work at Dow Jones. I work in support of their sort of news aggregation APIs and helping our clients do natural language processing with them. I've also worked in the past. You can see a couple of other companies I've worked with, Plotly in particular. We will be using a few of their tools, but Plotly is a really is a great data visualization platform. They have a few different ways of using it. And then IHS Global Insight, that's an economic forecasting company I used to work at. And then this last sort of image and logo from Beta NYC. This is just more sort of an interest of mine, which you'll see in a few of the assignments. I like using civic data in our assignments, and I think it's a very rich data source, and it's a really impactful way of developing data science skills. So this image in particular was a project I worked on looking at outer borough cab rides. So I had known of a few locations where you had cabs going to the nearest express stop on the subway, and they pick up multiple people. It's sort of this, what I saw as like a natural occurring cab share. And I knew of one or two of them, but I wanted to see if there was a way that I could visualize, is this happening elsewhere in the city? So this is actually the stop I knew about this is Forest Hills in Queens. And you could get a pretty clear idea visually of what's happening. So you have, sort of a distribution of cabs that are, and this is all terminating at the subway station, but this is where they're picking up. And, you see this pattern of, what's happening on this road here. And this is actually the road where cabbies will go up and down. They'll stop at the bus stations, pick people up for $2 and bring you to the express stop. So this ended up actually uncovering a lot of areas in the city where that was happening. So, I just sort of like this as a, source of, data and a way to really hone your skills. And then to introduce the class, really, I see this class at the end of the day as being about communication. So, in other courses in your degree, we're obviously looking at different techniques in dealing with quantitative information. This class is about how to use technology to present quantitative information. So this class will mainly be, you could think of this as a survey class. So if you've taken a look at the syllabus, you'll see sort of the different tools that we'll be using, and we're kind of moving back and forth between different tools and concepts. We're starting out in R, but we're going to move to Python, and we're going to sort of later move on to more interactive data visualization platforms, things like Shiny and Dash. And then lastly, we're going to move into some introductory JavaScript and D3. And especially as we get into the latter part of the class, one of the themes that I really get into is the fact that I consider data visualization to be the nexus between, one way of thinking of data visualization is the nexus between data science and web development, at least technologically. A lot of the D3 is a JavaScript library that is, an extremely powerful, tool to, build just, really unique visualizations. And, as we move on to later, to sort of later classes, we'll get more into kind of, these general web development concepts, and hopefully we'll get some understanding of JavaScript, because this is really the only class where you'll get exposure to that in this degree. And then just some general class logistics. There's a pretty, predictable pattern to the course. So in a week and a half, the first homework will be due, and every other week homeworks will be due. So it's a bi-weekly pattern with the assignments. There's a final project that will be completed at the end of the semester. And there will also be a proposal that I didn't post it yet, but the proposal will be due in the fourth module. So I'll make sure that gets posted ASAP. And then the only other real thing too, as I was talking about before, we have weekly discussion posts, which I would recommend, getting your posts in by Thursday, so that you have the rest of the weekend to, for students to respond to you and to respond to other classmates. And then lastly, I have the link to the GitHub here, and this most of the assignments, or all of the assignments, are posted on GitHub. So be sure you're watching that repo. So any questions on general logistics before we move on to some content? Cool. So, so for this first lecture, I'm going to be going through some visualization technique and theory. And actually, Sumya asked if I'll be posting the deck. I will. Thanks for reminding me. I'll provide a link in Module 1. And normally the meetups will be, in general, my philosophy towards, teaching the course is, I see this as being largely project-based. So, I do provide some, links to resources. Sometimes it'll simply be technical documentation for whatever tool that we're using. And, in general, I sort of see this as being a sort of learning by doing class. So, it's, we're going to be going through a lot of different tools. Each module will be switching to a new environment. And, really it's sort of, I'll give you, the project will sort of serve as your goal, and, sort of use that to sort of inform how you're getting a handle of the tool. Charles asked, are we supposed to be using Python or R? So yes is the answer to that. We're going to be using both Python and R. We're going to be using various frameworks from each. So we're going to start out with static visualizations in R, and then static visualizations in Python. Then we're going to move on to interactive visualizations. So we're going to be using the Shiny platform in R and the Dash platform in Python. And lastly, towards the end of the course, we're going to be getting into some basic JavaScript and D3. D3 is a library that is JavaScript based and is a low-level visualization library. And that's especially towards those last three modules where we're getting into Shiny, Dash, and JavaScript. We're going to also be getting into some basic web development concepts. And as I mentioned, I do see data visualization as sort of this intersection between web development and data science. But I also recognize that at the end of the day, this is a data science degree, and really that's the side that we're going to be working with. So so I'm not going to expect everyone to be JavaScript experts, and don't be afraid to sort of, especially for the final project, rely on tools like R or Python. That being said, I know in general this degree focuses a lot on R, and as a result, I sort of like trying to make sure that we do get exposure to Python in this course, just in my own professional experience, and I'm my own sort of client-facing professional experience. So like what I've seen out there, Python is very widely used, and I think that it that it's definitely a benefit to gain exposure to Python. And Zachary asked about using a Windows subsystem for Linux. So you have a Linux computer and you have something like Wine or like an emulator there?
Yeah, that's right.
Okay. So what I may, I'll have to think on this. My gut is telling me that like all of these tools that we're using, so in R and in Python, like for R, we'd be using RStudio. They both have Linux versions. So my gut is telling me what I would recommend is just stick with Linux, because really, like, if you're comfortable on Linux, like then these tools will work there. So I would say I wouldn't even focus on sort of getting things working in Windows. I would just sort of set up a Linux environment and be happy there. But all these tools will work in both environments as well as Macs. I'm on a Mac myself, so so that should be fine. Anything else before we get started? Cool. So first we'll talk a bit about the importance of data visualization. So does anyone know what this is a photo of?
Challenger explosion?
Yep. Yep. And someone put that in the chat as well. Yep. So this is indeed the Challenger explosion. Happened in 1986 and was just a tragedy for NASA and for everyone involved. But it's surprisingly partially a story about the importance of data visualization. And this material is coming from a thinker called Edward Tufte. He's sort of a very major thinker in the field of data science, and most of the concepts that we're going through in the discussion boards, for example, are going to be coming from his books. So he's a pretty important person in the field. And so getting back to the Challenger, what had happened was what's called an O-ring failure. So you could see you have your rockets, your fuselages. You have sort of two rockets on either side of the central red rocket, and you have what are called these O-rings. So you could see these kind of segments going up, and what caused the Challenger disaster was a fuel leak coming from one of the O-rings. So you could see you could see sort of the fuel starting to leak, spilling onto where the fire was. So you could sort of have an idea of really what was of what ended up causing the explosion. And like anything, being done on this scale, there was tons of testing of what was happening. So, you're building these rockets, you're doing, performance tests of them. And in particular, what this visualization is showing is what effect temperature has on the sort of success or failures of these launches. So what you have here, you have sort of each pair is representing a trial. So you have your two sides of the your two rockets, and if there's no marks, so this first run, this third run, if there's no marks, that is considered a successful run. And if you you sort of see marks of the where there was damage and giving information of what happened. So in this trial, there was this O-ring that was damaged. In this trial, you saw there's damage here, and for each trial, it gives you the temperature. So given this visualization, does anyone have an idea as to what the effect of temperature may be on the relative success or failure of these O-rings?
I think I remember that the lower the temperature, the higher the increase of failure.
You remember that, but is that clear? Does that seem to be what's happening in the visualization? Or does that seem to be clear?
I see 3 that are under 60, and all of them have some sort of failure. So
okay, yeah. So that is correct. And as you as you noted, you had three cases where there were below 60 and they had damage. But you also have some things like this one is 70 degrees and there's damage. This one's 75 degrees and there's 2 O-rings that were damaged. So it's harder to really get to that conclusion by looking at this particular visualization. And Tufte decided to reimagine, a clearer version of this visualization. So it's the exact same information, but it's plotted out in a different way. So we're looking at, and he's using what's called, O-ring damage index. You could sort of think of that as the number of O-rings that failed. And you have, temperature on the x-axis. And plotted out like this, you are able to, see these patterns a lot more clearly. So you actually see that, anything lower than 65 is pretty much resulting in a 100% failure rate. And while that's the case, it's also, not really something that's statistically significant, because you do have failures that are still occurring in these higher temperatures here. And, so you sort of have that going on. But looking at this visualization, it's a lot more clear what's going on. And also keep in mind, this is Cape Canaveral in Florida. So, this is sort of the normal, Florida range of temperatures. And this was just a very unseasonably cold day. So, this was actually in the 20s that the temperature was forecasted. So so you could see how, looking at this visualization, it, really sort of raises those visceral alarm bells way more than looking at something like this. And here we just have, a few other examples of, bad visualization. So anything from, pie chart where it's obviously not, the correct way of displaying this information, given that we're not adding up to 100, or something like, where we're picking some sort of, circular way of looking at looking at a day. It's kind of, we're looking at temporal data, but you sort of have noon and midnight on either side. So that's very confusing in terms of what's showing up there. These other two, does anyone have any ideas as to why this line chart might be a bad visualization? Yep, Sudan, you're right. It's too much information, too much noise. And we'll get into a few strategies of dealing with this, but really, when everything is over plotted, there's just no way of differentiating. And one of Tufte's principles is called the principle of small multiples, which would allow people to differentiate between these rather than having them all plotted over each other. And then lastly, this bar chart here. What's problematic about this bar chart? Yep, Sudan, you're right there as well. The years, and this one is actually a horrible graph for multiple reasons. So the years aren't in order, wrong order in the x-axis. There's also just simply looking at the numbers. A bar chart has, with a bar chart, it's it doesn't lend itself to this cutting off of the y-axis because we have this 55-degree temperature here. 55 is not twice as much as 54. So you could see how visually it seems like things are getting drastically worse. Things are warming, but it's not like things are twice as warm in 2012 as they were in 98. So here you could see just kind of a few main points of what the goals of data visualization are. And we'll sort of use this to look at a few sort of guiding principles in data visualization, like a lot of that coming from Tufte. We'll also be going through a few other sort of thinkers in the field, and one of the things I like doing is sort of looking at these things from multiple angles. So we'll look at a few different thinkers and sort of look at different reframings of these concepts. But you could sort of think of these as really this is centered around communication. You want, like, images are more clear than numbers. So, you're more likely to, if you see a table, you're not going to, viscerally understand what's happening as easy as seeing a trend line showing something going up and then down, really showing what's happening with the trend. Likewise with memory, with making the information easier to retain. Memory is visual, so it's easier to sort of recall a visualization rather than recall raw data, which I imagine is true for most people here. And then lastly, sort of what matters is insight. So this is sort of more. Communication is what matters. Obviously, it would be great if we could aim for beauty as well, but the core of what we should be focusing on is insight and how effective a communication tool this data visualization is. And then we have a few strategies that we could use. So here we have matching the display to data and purpose, maximizing the information to ink ratio, and sort of working with small multiples. And I'll sort of be going through each of these one by one. So starting out, and I didn't post it yet, but I will post this in the first module. But this is a professor named Tamara Munzner, who she sort of has a different take on visualization. She looks at a lot of the same concepts that Tufte arrives at. She arrives at a lot of the same concepts that Tufte arrives at, but she's looking at it from more of a neuroscientific basis. So she does a lot of studies of sort of of human awareness and sort of relating that to data visualization. So it's a lot of interesting stuff from her. But before I get there, just sort of looking at the three main types of data. So we have relational, spatial, and tabular. Tabular data, that's the vast majority of data that we're working with, and we'll get into the different subtypes there. But first, we'll sort of look at these other types, relational and spatial. So relational data, you could really think of as just being links between points, links between entities. So things like family trees, looking at international trade, so looking at bilateral country pairs and comparing them, that's sort of relational data. This visualization that we're looking at right now, dividing the different data types, this is actually relational data that we're seeing. So, like relational data, it's not often seen, but these are really the main types of data that you would see there. And then with spatial data, what really matters here is that there is an intrinsic, some sort of intrinsic quality of the data. So the 9 times out of 10, when you're looking at spatial data, you're going to be thinking maps. So when I'm talking about longitude and latitude, and I'm referencing a point on a map, that's referring to a particular point in space. And maps are really the most, the vastly most common type of spatial data. But you could also think of things like star maps or the position of stars in constellations. Those are also corresponding to intrinsic positions, and but it's sort of different than what you would think of as a traditional map. And then moving on to the more frequently encountered data, tabular data, you can see we have three main types over here. We have categorical, continuous, and discrete. So providing examples of each. Categorical data, it's this sort of data is distinct, discrete. So you could have different types of fruit, different types, different countries. If we're not mapping things out, if we're just simply looking at countries as categories, that could be a form of categorical data. And then, so that's sort of categorical. And then we have different types of ordered data. So if you're ordered, but you're still discrete, and here the example is sort of small, medium, large, or extra large. It's very similar to categorical data, but the only difference being that the order matters. So we have our discrete categories here, but there's also a relationship between them. Extra large is bigger than large is bigger than medium, etc. If you're thinking of something like phases of a project, for example, phase 1 through phase 5, those would be discrete, ordered data. And then lastly, we have continuous data. And continuous data, sometimes called numeric data, really what this just means is it's a measure. And it's a measure, and that measure could be anywhere along a scale. So if we're talking, in this case, 5 kilos, 2 ounces, that's a weight. And things could weigh anywhere, they could weigh like just over 0 pounds to, or 0 kilos to, tons. And it's, you could be anywhere in between. It's a continuous scale, not something that's discrete. Any questions on just the typology of data before we begin sort of matching these to different displays? Cool. So what we're going to be looking at is, with each of these data types, we're going to try to look at like what sort of display strategies can we use. So starting out with spatial, that's sort of the most straightforward. If you're looking at spatial data, you're going to be in map land. So you have a map. That map is corresponding to locations on physical locations, and that's pretty much it. There's not really much variation in terms of spatial data. Getting to relational data, however, you begin to notice like really what we're talking about when we're talking about matching the display. So we're not you'll notice these these are sort of more obscure concepts rather than a bar chart or a line chart. And that's by design, because and this is all coming from Tamara Munzner's work, where really she's looking at sort of these core elemental things that are happening in data visualization. So if you rather than thinking about a scatter plot, you're thinking about the fact that there's a point that has a position in XY space, and what you're doing as a consumer of that visualization is sort of comparing the positions of all of these points. So, with that in mind, taking a look at the first, display option here, contain. Can anyone think of a sort of visualization type that uses this strategy? So think about what's happening here. We have sort of a collection of points. Some points are inside, some points are outside. There might be other containers that sort of show different relational information. Using a band on a scatter plot. Could sort of think of that. A scatter plot wouldn't really be showing relational data, although although that is definitely sort of using the contain. It's using the contain method. So you're right in terms of like sort of using bands, using if you're in the economics field, using things like recession bars that very clearly sort of demarcates that these areas are recessions, areas outside it aren't. One example using relational data, however, is a Venn diagram. So with a Venn diagram, you have two sets. You're looking at sort of the relation between members of these sets, and you're using contain to sort of see. You can imagine like if you had another box sort of drawn over here, sort of maybe around these two, and you could sort of see that how you could look at something like this as as using the contain method. So that's what we mean when we're sort of looking at these strategies and trying to map them to other visualization types. And also these are in order of best to sort of best to worst. So contain works better than connect, which we're using over here. And then as we move on to ordered and categorical data, we'll get an idea of, of things that map more clearly onto known visualization types. So looking at position, that's a scatter plot basically. A length, looking at length, that you could think of as sort of bar charts, etc. And this example here, ordered data, I think sort of provides the most intuitive way of thinking about why something like length is better to use than something like shade, like area or shade. So one thing to think of is when we are so actually, and first, well, no, so sticking with length as an example. I imagine most people would be able to pretty easily tell which of these bars is longer than the other. Does anyone want to take a guess as to roughly how much longer the longer bar is than the shorter bar? Yep, Sumya, 25%, 20%. That's pretty much pretty much in line with what it looks like is happening here. Really the intuitive way to think of it is that was pretty easy to deduce when you were looking at length. But imagine if I asked the same question about area. If I asked, how much bigger is this bigger square than the smaller square? Could probably work it out, especially since they're squares, but imagine if they were circles, or imagine if they were, weird shapes, weird polygonal shapes. It would be pretty difficult to sort of, yeah. So Peter, you think it's around 50%, although be careful about that because it's at least looking at the length, I could sort of think of this as being half of that length, this as being maybe roughly half that. But because we're thinking about area, if this length is half of this length is half of this, what we really have is a rectangle that is a quarter of the size of the larger rectangle. And, so like you could work it out, especially with squares, because it's easy to calculate the area. But you don't have the same the same intuition that you had with length. There's not, you're not really sort of doing work to try to compare these two lengths. I imagine for most people on the call, you just know that like there's roughly this relationship between these two lengths, and we'll get into in a few slides, what particularly that means. But the way to, in terms of matching display to data, what that really means is length is a better strategy than area when you're dealing with magnitudes. And then similarly, we have different strategies with categorical data. So, position is, again, pretty easy to discriminate. We have color. So that's sort of a very common differentiator used in data visualizations, and then things like shape or pattern. I didn't mean to go there before introducing that next slide. So another way to try to gain an intuition of this, and I'll quickly go to that slide once more, but what I want you to try to keep, what I'm going to ask you is sort of what sorts of things pop into your mind when you see this for a split second. So, what did everyone see in that graph? Like, what is sort of popping out to you with what we just saw there? Like, did you see shapes, lines? So Peter mentioned a large increase of something, it's peaking and then dropping. I'm sorry, Sue. Yeah, so looking at sort of the different categories there. Getting back to Peter's comment, so what you noticed was sort of something that peaks and then drops. So we already have sort of a lot of information baked into there. Just simply saying it peaks then drops kind of is assuming that there's some sort of change happening, that there is something to peak and something to drop. So intuitively, like that's sort of what just first stuck out to Peter. And, so what we are looking at is housing prices. So, the most important channel that we wanted to use was for housing price. So for housing price and time, we're using position, time sort of moving along the x-axis, price being positioned along the y. And then we're using color, sort of a lower ranked channel, to differentiate between different cities. So the thing that stuck out the most to Peter, looking at this for a split second, was that there was something rose and then fell. It wasn't that there were two things. It wasn't that there were in this case two things selected out of multiple cities. That wasn't linked to a highly ranked channel. There were other things that took precedence when I was jogging back and forth very quickly. And because we're in the first module, I'm just throwing in some ggplot syntax. So when we're, and I'll get into this with some later meetups, the grammar of graphics, it's what I would consider a high level visualization language. And, so there's a lot you know, like I find this is a pretty useful way of thinking of visualization. So, you know, you sort of have variables mapped to these various channels, these aesthetics as they're called in ggplot. So you have, you know, year being mapped to your x-axis, price being mapped to your y, and city being mapped to color. So next, we have the concept of maximizing your information to ink ratio. So this is something where, you know, you have, you could think of this as just minimalization in data visualizations, and you're aiming towards efficiency. So, you know, less is more in a lot of cases. This is really getting back to Tufte's concepts. Like, this is really core in his thinking on data visualization. And taken to its logical extreme, you have what are called spark lines. And even I'll have examples of an even more logical extreme where you're not even focusing on the trend, you're just simply focusing on sort of a point-to-point change. And, you know, you draw a line between those 2 points, you have a visualization of that where you're even removing the trend lines. So so basically the, you know, spark lines are sort of this, you know, logical conclusion of this. And lastly, we have the principle of small multiples. So this is sort of the best practice to making comparisons of items. So, you know, stock prices are someplace where it becomes immediately apparent why this is useful. You know, with stock prices, what we're focusing on is the changes in price. So we're looking at you know, trends. We're looking at sort of is this behavior comparable to, you know, another company's behavior, and looking at Apple and BlackBerry, for example, they're at different levels. You have your, you know, you have sort of hundreds of dollars when you're talking about Apple versus single digits when you're talking about BlackBerry. And BlackBerry is, and BlackBerry is, you know, at a lower number, and the and BlackBerry's at a lower number, so you have different, you know, sort of numbers. But what really matters is the sort of trend there. So you have this sort of downward, you have this downward trend here, and it's sort of moving on upward there. So if you were to try to plot these on the same plot, you would end up with, you know, sort of a scale going from single digits to hundreds. You would have Apple just purely up there, BlackBerry down at the bottom, and there would be no, you know, no real information to gain aside from the fact that Apple prices are just that much higher consistently than BlackBerry prices. And again, just sort of relating this to ggplot, because you know, we're sort of in the R module. You could you know, also think of this in terms of mapping these variables to aesthetics. So we're looking at date, we're looking at price, and we're you know, sort of using this third variable company name, we're mapping that to facets. So in ggplot, that's called facet wrap, and you know, you could think of that as sort of the third variable that's being mapped there.
I actually had a question on that previous one. Is there something to say about the different graphs being on different scales? And your comment below, before, like for example, Apple, that drop isn't as much as BlackBerry. I mean, should we better be using percentages so we can link them better?
Yep. So yeah.
So when I'm trying to compare Apple to BlackBerry and the drop in BlackBerry, I mean in Apple at the beginning, the increase in BlackBerry. at the end, that scale doesn't really tell me how much more money or less money I'm making with one stock or another, right?
You're absolutely right about that, and actually, this is pulling from another data visualization thinker, Scott Baronato, who suggests that the another way of making these, like, sort of thinking about comparisons is thinking, are your measures comparable? So when we're looking at sort of just the raw the kind of the actual price of the stock isn't what's of concern. It's not really. It doesn't matter that Apple stocks are trading at this price and BlackBerry stocks are trading at sort of in this scale. What matters is sort of what was the behavior of Apple versus what was the behavior of BlackBerry. And using this as an example, Scott is like sort of in this like bad example, and this is actually worse than even what we were like. Dual y-axes are almost never a good idea, and when you're plotting these out, like, you're avoiding sort of having the scales totally out of whack. So you do have this kind of you are able to see that the pattern is similar, but you're absolutely right that, like, because they're not comparable, you're losing information. And when you do look at the price change by, so looking at this graph, you clearly see that there's a mirror, there's similar movement happening between gold and silver, but with percentage change, you get a clear idea of what's happening. And really what's happening is there are similar movements, but silver has higher highs and lower lows. And so there's more variability in terms of what's happening with silver prices. So you're absolutely right there that even looking at something like this, it at least makes them comparable. But looking at price change gives you just that much more information. So that was a good catch. And then looking at these different principles in practice, like you could see a few examples here that everyone's probably come across. Like looking at this, for example, you have a bunch of funds, and you're looking at trend lines, and it's pretty clear that there's something off about one of these. Does anyone, by the way, have an idea as to why one of these is different? Or at least everyone's seeing that there is one that's sort of not one of these is not like the other. Does PIMCO look like a bit different than what's happening with the others? I think there's some similarities, but there's definitely like more similarities between between these. And in this case, it's actually everything else is stock funds, and PIMCO is a bond fund. So it's sort of categorically a different asset class, and that's why it's behaving in a different way. And this is getting back to Scott Baronato and just talking about how these strategies can be reframed. So Scott reframes this in terms of saying that the choices that you're making in visualizations should be informed by the point that you're trying to get across. So it's similar to Tufte, but it's more linked to the fact that data visualization is about communication. And it's like you can't really separate your visualization choices from the fact that you are trying to communicate something, and your visualization is in service of that. So, and the way I sort of frame it is as a conceptual version of the maximizing the information to ink ratio. So so here, as an example of this conceptual, this conceptual maximizing data ink ratio, we have some text here with some figures talking about census information across rural, suburban versus urban areas. And then we have the exact same, content shown visually. So, part of this you could sort of think of as a picture is worth 1,000 words. Part of this, and this is what I was mentioning before, that this is even getting more extreme than spark lines. We're looking at sort of a point-to-point change, and all we're interested in is what's happening at the start, what's happening at the end. This is over a period of a year, but if we were looking at a longer time period, you could imagine, what the sort of the sort of decision that we're making is we're not even concerned about what's happening in between those two periods. We're just sort of, all we're focused on is what was the start, what was the end. Here's a visualization that shows that growth, and maybe there could have been a peak and then going back down here or something like that. So this is just another way of reframing those sorts of visualization strategies, and then relating this back to how this really comes down to communication. Here we have a visualization that seems to be telling a story. So we're looking at vinyl sales since 1993, and at first brush, someone looking at a graph like this may think that modern day hipsters are driving vinyl sales to unprecedented levels. We had sort of our 90s baseline, and all of a sudden, this is like really increasing. But context matters. So, really, things aren't being driven to unprecedented levels. Things change drastically when you begin to sort of widen your focus. And, you could sort of think of this as, sort of a general tip when you're kind of looking at, any sort of information really, is think about the context that the information is being presented in, and try to find, if you're questioning the information that you're being given, try to think, is there another context that could make things clearer? So I'm going to sort of move quickly through these last few slides. We're almost at the end here, and then we'll quickly talk about assignment 1. So this slide here, this is sort of getting on a point I was talking about when we were looking at Tamara Munzner's concepts. And this is a more formalized way of showing what how essentially how human perception works with various types of stimuli. So what I'd mentioned about length, I said, and the way I put it was, it's usually pretty easy to tell, like, is one line twice as long as another line? And in that case, that would be sort of that perceived sensation. So I perceive this line to be twice as long as this line. That's sort of what's being shown on this axis, on the y-axis. And then on the x-axis, you have the actual intensity. So in reality, what is happening? And length, it's a one-to-one relationship. Humans are really good at making judgments in terms of length. With area, not so much. With area, there is actually, the perceived sensation is weaker than what the actual intensity is. And, you could sort of map that onto a specific factor that that area is. And similarly with all these other measures. So, when you're looking at area, like, you're sort of underestimating what the actual reality is. When you're looking at things like saturation, you're overestimating. You're really overestimating when you're thinking of electric current, which would be an interesting choice in data visualization. But just keep that in mind if you decide to use that. And then and then to sort of think about discrimination, this is another reframing of these concepts. So, pie charts at the end of the day are showing things in terms of area, and the humans aren't good at making the judgments of area. So it's usually not the best idea to provide too many categories in a pie chart, and then sort of similar rules for colors and overlapping lines. So with this last slide, there's a lot going on here, and what I want to do is to try to put a lot of these concepts to test and really, try to get an idea of, of how can we judge, what is a successful visualization and what isn't. So, so what this is showing is, and what I thought would be interesting would be to, show a political map that, assuming most people on this call are very familiar with American politics, show a political map that isn't as knowable as, or, that everyone, doesn't know the story of, So here, what we're actually looking at is the 2011 the Canadian federal election. So there is a lot here. There's two main visualizations. There's this, which is showing election results by riding. So riding is basically like the U.S. House of Representatives. Like there's just a bunch of districts allocated by population. And, this is parliamentary system, so we have more parties than just simply Democrat and Democrat and Republican. And then we have this visualization on the left-hand side where we're actually getting information about the change in seats. So if one of these blocks is solid, that means that it was, it stayed with the party last election, nothing changed. If there was a change, you'll see like there's sort of a little color showing the previous party that was there. So what I thought would be interesting to do is to try to, assuming people aren't as well versed in Canadian politics, and if you are, let's try to give people who aren't as well versed a chance to answer. But what I want to see is, just sort of, is this a successful visualization? Are we able to, without, based on the visualization alone, be able to, have some information communicated to us? So take a minute to look at this and let me know if there's any sort of, stylized fact or, sort of story that you could try to pull out of this. And also just to make sure everyone can clearly see everything, right? Cool. So we could start out with just kind of simple observations. So, for example, we have this is Quebec right here. We could say something simple like the New Democratic Party really seems to have done well in Quebec. And looking at the left-hand side here, we could get even more information about what's happening there. And Quebec is actually a pretty, that was one of the more interesting locations during this election because of, what was happening. So looking at, here's Quebec over here, and you could see a lot of change in terms of in terms of what was happening with the parties. So there's a lot of seats where you have this light blue, the party called Bloc Québécois, losing to the New Democratic Party. You also have this block of liberal seats, the Red Party being sort of swayed into New Democratic, and yeah, so there's, you sort of, without any knowledge of, Canadian politics, you're able to sort of see, it seems like there were some shifts happening. You have, we have an absolute majority, so the Conservatives ended up winning this election, but, you could sort of see, get a bit of an idea as to, what the story might be. And it turned out this was a pretty interesting election. There was the New Democratic Party, NDP. There was a surge of this party that for a while, normally in Canadian politics, the two major parties are Conservative and Liberal. The Liberals actually came back now, so that's why Trudeau is the Prime Minister. And but in this election, the New Democratic Party did very well, and it was in particular at the expense of the Liberal Party and the Bloc Québécois. So they became the official party of the opposition. And I'm a McGill alum myself, and this was actually, there were a few McGill students who were running for office. They just wanted to have a run on their resume, and they never expected to win because these were solid Liberal seats or solid Bloc Québécois seats, and as a result, there were just 4 current students of McGill at that time that were elected to Parliament. So there were quite a few major changes in that election, and it's with something so. With that story, we could now sort of ask a new question. So, the new question would be, is this a successful visualization? So what do people on the call think? Yep. So Sudan mentioned it's a bit too confusing. I think it's debatable. There are good and bad aspects of this visualization. The one thing that I think in particular adds to confusion is if you sort of pay close attention to what this scale is showing. We have 5 parties, and we have, in addition, this kind of extra dimension of how well the winning party did within the within their particular riding. And I in particular think that this is a bit too much to handle. The combination of the two, you could see you end up with roughly 25 separate colors, and especially when you have sort of the high popular vote, it's hard to distinguish what what these seats are. Especially if you're not well versed in Canadian politics. You don't if a Canadian would look at this, they would say, of course, the Bloc Québécois isn't winning in Alberta. That's Alberta. I forgot my own provinces there. But if you look at the colors, it's kind of hard to tell. is this Bloc Québécois? Is it conservative? You don't really know there. And yeah, Johannes, you have a very good point that for a general audience, it's confusing, but also that's something that you need to think of when you're creating data visualizations. Think about your audience, and if you have, if this were created for a Canadian audience, it's a more successful visualization. So, audience is something that that really kind of makes that decision there. So we're a bit over here, and I don't want to keep us for that much longer. So I'm just going to move to the homework 1 and see if anyone has any questions here. So the first homework assignment, we're looking at, we're using R. We're looking at, sort of company level data. So you could see we're reading in some data here. We have various companies and different stats on them. And we'll be answering some questions about them. So, just in terms of the logistics of it, like our Markdown document is, a pretty ready-made template for the project. Just answer the questions right in the code blocks. But does anyone else have any questions on homework 1? Cool. So if you do, Peter. So Peter asked if we submit on GitHub. So submit on Blackboard, but like I do appreciate I do like sort of encouraging GitHub use. So as you're sort of working on your own repo, you could just simply provide a link in GitHub. I just want Blackboard to be the kind of official record of the course. So make sure you submit there as well. Yeah. Yep, Sudan. The GitHub link would be fine. Yep, so Sumya, it's the third question. Do you mean the second question?
No, what I mean is the third question that we have over there, it says, it says about if you're an investor and you're looking at industries that generate the most revenue per employee. So the question is that question referring to applying a filter for the that is the third most number of companies as identified in question number 2, or is it across the country? What industries are generating in terms of revenue per employee? So should we filter or for the state as we identified in question number 2, or is it a more generic across the country kind of question?
It's general across the country.
Okay, got it.
Yep.
Thank you.
You're welcome. Anything else? All right, so that'll be it for tonight. The first homework, as I mentioned, will be due on in a week and a half. The exact date is posted. I'm not remembering it right now, but and then homeworks will be every 2 weeks thereafter. And if anyone has any other questions, use the forum, the Ask the Instructor forum, if you have any questions that you feel other students could benefit from, or if it's more specific or personal, feel free to email me directly. Email is the best way to get a handle, to contact me, and that should be in my contact information on Blackboard. So with that, thank you everyone for a good first meetup, and I look forward to the rest of the class. All right. Thanks a lot, everyone. Good night.
Good night.